In this lecture, we will introduce the notion of class inheritance.
If you recall from CS 121, we talked about this idea of a class. So if you remember, in a class, we are describing the attributes and the operations that can be performed on some particular object of that class. So what we're doing here is we're combining the data and the operations into this single unit, which we called a class. And this idea, this process of combining everything into a class is what we call encapsulation. But this isn't the only thing that we can actually do with classes and objects. There are a ton of different things that we can do with classes in an object-oriented programming language. For example, and this is what we're going to be talking about a little bit, is we can create brand new classes by using the data and operations and attributes and methods and all that from other classes that already exist. Instead of having to create brand new classes from scratch, we can take components of already existing classes into our new classes. And we'll see how this actually applies to inheritance. And one of the advantages of using this is it encourages code reuse. So we don't have to rewrite all this code from the beginning. We can take code that already exists and add some additional features to these new classes. In fact, this idea of reusing code is a major goal in object-oriented programming. Let's take a look at an example. Let's say we want to create a class that includes information about a clock. So the hour, the minute, the second, changing the hour, minute, second, and so forth. But we also want to include information about the time zone. Well, if you remember in CS 121, we've already implemented a class that involves the clock, which we call the clock class. And we spent a good amount of time describing all of the attributes and the methods associated with that class. So one thing we could do is we could just go back to that clock class and make changes to it and add the information about the time zone. But our claim here is that's not necessary. We don't need to create a brand new class and rewrite everything we did in the clock class. Instead, what we can do is create a new class, but instead of re-adding everything that was done in the clock class, we can extend the clock class. So we can just bring it in automatically and then add the additional features that we want. This mechanism that lets us extend the definition of a particular class without making any major changes to it is what we call inheritance. So when we inherit a class, we're automatically bringing in everything that existed in that class. And the key thing about this feature, this mechanism, is that we don't have to make any changes to the existing class. So if we go back to our clock example, I don't need to make any changes to the clock class. I can just inherit the clock class into the new class that I create. And it's going to have the hour, the minute, the second, and the get time, set time, and all the other operations that were in that class. But I don't need to make any changes to the clock class at all. A way you can think of inheritance is kind of this is a relationship. So what we say here is we have this extended class, and we're just basically saying that it is a previous class. So just to give an example with the clock class, every extended clock is a clock. So whenever we create a new class, every new class is the same thing as the old class. It's just we're going to add some new stuff to it. Whenever we're dealing with inheritance, we need to have this distinction between the original class and the new class that we create. So we're going to say that any new class that we create from an existing class, we're going to call a subclass or derived class. I'm probably going to use subclass a lot in this course. And then the existing class or the original class are what we call the superclass, or also called the base class. Once again, I'm probably going to use superclass over base class. And by having this relationship between the subclass and the superclass, we can actually inherit features from the superclass into the subclass. Now, with that said, the subclass can have its own additional attributes and operations and methods. But what we're doing here is whenever we inherit from a superclass, the subclass has everything that the superclass originally had, and then we can tack on additional attributes and methods on top of it. So what we're trying to do here is instead of having to create a brand new class from scratch, we can just simply reuse the superclass in the subclass. Let's take a look at the syntax for deriving a class from an already existing class. So we would have something like this. The beginning part is no different than what we've done before with classes. We would have some set of modifiers, usually something like public or private, the keyword class, and then the name of the class. What comes afterwards is what's different and tells us that we're inheriting something from a superclass. So we have this keyword extends right here. So the extends part tells us that we're going to be inheriting from another class. The existing class name, that is the superclass, the class that we're inheriting from. And then there could be some additional modifiers that come afterwards. A lot of times it's not there, but sometimes we do include some additional modifiers. Then we have our pair of curly braces, and then we would have our list of members. So our attributes, our variables, we'd have our constructors, and the other methods and operations that we would have in here. So let's take a look at a simple example. So maybe we have something like this: public class circle extends shape. So what this is saying is I'm going to create a class that's called circle, and I'm going to inherit all of the variables and methods from the shape class. So in this case, circle would be the subclass and shape would be the superclass. Now, there are some rules that we have to consider whenever we're inheriting from the superclass to the subclass. The first rule is that the private members of the superclass are private to the subclass. In other words, subclasses cannot directly access the private members of the superclass. So as we've said before in CS 121, if a member is private, no other class except the original class can directly access it. This includes subclasses. The second rule, it deals with the public members. So a subclass can directly access the public members of the superclass. Since the member is public, any other class can directly access it, which includes the subclass. The third rule is that the subclass can include additional data and or method members. So a subclass is not limited to just whatever the subclass had. It can create its own variables, it can create its own methods. In fact, we normally do this whenever we inherit from a superclass, that we add additional variables and additional methods on top of it. The fourth rule deals with methods that we want to make changes to. So if we bring in a method, we can actually override it or redefine public methods of the superclass. So what do we mean by overriding a method? Well, the subclass can have a method that has the same name, the number of parameters, and the type of parameters as a method in the superclass. And then we can just change what we put inside the body of that method, but the name and the parameters are the exact same. Now, we only use this for objects of the subclass. We don't use this for objects of the superclass. In fact, we've done this before. If you remember the toString method, that's a method that's given to us automatically whenever we create a class. But we redefine it, because remember, if we don't make any changes to it, it prints out the name of the class and some weird hash code. But we usually redefine it to print whatever we want to actually print. So that's an example of where we're overriding a method. So what we're saying here is we can do this with other methods as well in the subclass. And then the last rule is that all data members of the superclass are also data members of the subclass. So we're automatically given all of the methods of the superclass. Now the data, if they're private, we can't directly access them, but any method that is defined in the superclass, we're given automatically in the subclass. When we're talking about inheritance, we're not limited to just a superclass and then a subclass. We can actually think of this more like a hierarchy, kind of like a chain of subclass to superclass. And what we find is that a subclass can actually become a superclass for a future subclass. So we can have a subclass and then a subclass of that and then a subclass of that and so forth. So we can have this chain of subclasses. We can even take it a step further, where inheritance can either be single inheritance or multiple inheritance. So what do we mean by that? Well, with single inheritance, the subclass is derived from a single superclass. So we're inheriting from just one and only one superclass. With multiple inheritance, the subclass is actually derived from more than one superclass. So we can actually have multiple superclasses and inherit everything from all those classes into a single subclass. Now, I should mention that in Java, it supports only single inheritance. So a Java class can extend the definition of only one class.